In the last part of the program, we looked at some of the preparations that are generally made before performing a shaft alignment. We discussed inspecting the foundation, the mounting base, and the motor feet. We also looked at what's involved in checking for pipe strain and soft foot. In this part of the program, we'll continue our discussion on preparing for an alignment. One preparation that's generally made prior to performing a shaft alignment is determining the thermal growth characteristics of both the fixed and the movable components. Thermal growth is a term used to describe the physical movement that occurs as a piece of rotating equipment reaches its normal operating temperature. Different types of rotating equipment have different thermal growth characteristics. For example, when a motor is started up, it produces heat. This heat causes the motor housing to expand, which in turn causes the shaft to rise slightly. On the other hand, a pump that pumps cold liquid has a different thermal growth characteristic. In this situation, the cold liquid passing through the pump causes the pump housing to contract. This then causes the shaft to lower slightly. For that reason, the thermal growth characteristics of both the fixed and the movable components must be determined and taken into account when performing an alignment. Some equipment manufacturers determine the thermal growth characteristics for their products, so you may be able to find this information by checking the equipment manuals for the components you'll be aligning. However, if this information isn't available, it may be necessary to measure the actual thermal growth of the components. Your facility may have procedures on how thermal growth is measured. You'll also find descriptions of a couple of ways of doing it in your text. Up to this point, we've discussed most of the preparations that are made before performing an alignment. The order in which you perform these preparations hasn't been critical so far. However, the last preparation we'll discuss should be the last one done before actually aligning the shafts. It's called setting the face gap of the hubs. Most couplings are designed to operate with a specified amount of space or gap between the faces of the hubs. The purpose of the face gap is to prevent damage to the hubs and coupling from axial movements of the shafts. The term axial movement refers to the amount of movement back and forth that is allowed by the bearings that support the shafts. If the face gap is too narrow, axial movement may cause the two hubs to contact each other and become damaged. On the other hand, if the face gap is too wide, the coupling may separate and be damaged. You'll need to check the coupling manufacturer's specifications to determine the gap that's required for the particular coupling you're using. For example, these specifications show that this hub should have a minimum gap of 1/16 inch, or 62.5 mils. The maximum gap for this hub is 5/32 of an inch, or 156 1/4 mils. You'll also notice that the ideal or normal gap for this hub is 1/8 inch, or 125 mils. With the gap set at 125 mils, the coupling should be able to handle axial movement of the two shafts without damage. In order to set the face gap, the motor must be moved into position. It's a good idea to eyeball the two hubs to get them reasonably close to being aligned while adjusting the coupling face gap. This will make it easier to take misalignment readings later on. Many mechanics will use a straight edge and feeler gauges at this stage to get the two shafts close to proper alignment. Now, you'll need to get a feeler gauge the size of the ideal face gap specification that was determined earlier and insert it between the two hubs. You may have to move the motor to get the face gap set to specifications. Finally, the motor support bolts should be tightened. Setting the face gap for that pump and motor was fairly easy because both components involved bearings that held the shafts in their normal operating position. So axial movement was minimal. However, when larger equipment is involved, particularly components that have sliding surface bearings, much more axial movement may occur. So in those situations, you may have to perform some additional steps before setting the face gap. One step you may have to perform is determining the mechanical center of the fixed component. That is, finding the normal operating position of its shaft. To determine the mechanical center of a pump, this mechanic first forces the pump shaft inward as far as it will go. Then a dial indicator is mounted so that its stem contacts the face of the pump's hub. And the dial indicator is adjusted for a 0 reading. Since the stem was partially compressed when the dial indicator was mounted, the small needle reads 1, meaning 100 mils, when it was zeroed. We'll need to keep this in mind when we take the final reading. Since we need to determine the total amount of axial shaft movement, the next step is to force the shaft outward as far as it will go. Next, the reading on the dial indicator is checked. In this case, the small needle reads 2, meaning that at least 100 mils of travel occurred. The large needle indicates 31.5, so the total travel was 131.5 mils. This reading is the total amount of axial shaft movement. To determine the mechanical center, we'd have to divide the reading by 2, which would be 65 3/4 mils in this example. After the mechanical center is determined, the shaft would have to be moved back inward half the total movement to set the pump shaft on its mechanical center. Then the face gap could be set to the ideal specification. Axial movement is present in motors just like any other piece of rotating equipment. However, because of the magnetic field that is created by the field windings in the motor, the rotor is held in the same position each time the motor is operating. This characteristic is referred to as the motor's magnetic center. Like mechanical center, you may have to determine the magnetic center of the motor before adjusting the coupling face gap. In some cases, the magnetic center for a motor is specified in the manufacturer's manual. However, if this information isn't available, it's possible to determine it while the motor is running. Before determining the magnetic center of a motor, you'll need to ensure that the motor is properly secured to prevent the motor from getting away from you when it's started. Here, the hub and coupling parts have been removed. If this isn't possible, loose coupling parts should be restrained so that they won't fly off when the motor's started. Now the motor can be started. As you can see, there's a great deal of axial movement as the motor comes up to speed. Once it's reached its normal operating speed, its magnetic center can be determined by first spraying the shaft with layout dye. Next, scribe a line on the shaft using the end bell or similar part of the motor as a reference point. When the motor is turned off, and this mark is lined up with the reference point, as it is here, it indicates that the motor shaft is at magnetic center. At that point, the face gap can be set to the ideal specification.